So in less than 5, 4, 3, 2, 1, and go. Okay. Good day, everyone. Good day, good morning, good evening, wherever you are in the world. Welcome to another section brought to you by your BizEdge. For today's session, we'll be having a special guest, Byron Neji. We'll be taking us on the topic, Crack the Code of Data Engineering. Okay, so this session was brought to you by the collaboration between two partners, which is your BizEdge and also MHS Analytics. So for some of you that might be in Canada, we have a new sponsor and a new partner, MHX Analytics. So if you're in Canada and you want to take training in data analysis using Excel, using Python, using SQL, or financial modeling, you can also reach out to MHS Analytics in Canada. And their main motto is basically they are committed to giving their client the business intelligent edge they need using tools they already have. So tools like Excel, Python, SQL, and Power BI. So they offer trainings like big data, so that's big data analytics in Excel using Power Pivot, Power Query, and also VBA. They also offer business intelligence using Power BI. That's for automation, DAX, and visualization. They also offer automation using Python. That's for data analysis using Python, where you get to use Matplot, LIB, Pandas, and some other libraries. And also SQL for data analysis. So for our company, your Visage, right? So your Visage is a registered Microsoft Excel consulting, financial modeling, business intelligence, data analysis, and also enterprise solution firm in Nigeria. Your business also specializes in helping companies and high-value professionals be on top of the business data. They're also the developers of some financial and data tools, which you can also find on Microsoft Office Store, such as the Nigerian Finance Market Analysis tool, which is available on Microsoft Office Store and also available on the Excel store. If you just go to Excel Insert and search for Nigeria, you see it. Also, the developer of the Nigerian stock analysis dashboard and also many other tools which you can also find on Microsoft Office store. We're also a training company with branches in Lagos, Port Harcourt, and Abuja. On it and some of our upcoming training, this is our calendar. So on the 7th of July, we're having big data analysis, Power Query, Power Pivot, and VBA. For some of you that might be interested in taking your data analysis skills in Excel to the next level, you can check us up on the 7th of July. On the 11th of July, we're having Python for data analysis. So for some of you that might be interested in machine learning algorithm, data science, and some other interesting tools, you can also check us up on the 11th of July. That's Python for data analysis using Pandas and Matplot, LIB, and some other visualization and analysis tools. On the 9th of June, which that's actually past. So this is actually older calendar. So sorry. Okay, so our special guest, Byron, right? So he's a data engineer. So I'll just give you a brief about him and I'll hand over the section to him. So Byron is a data engineer with passion in uncovering insights and driving innovation. With over 3 years of experience and background in data analysis, Byron thrives for leveraging the full potential of data. He's a certified AWS practitioner, that's Amazon Web Service. He's skilled in various tools such as AWS, Adobe, that's for big data, that's Hive, HBI, and PySpark. Byron is passionate about tracking complex data engineering challenge. He's currently the lead of 10 Analytics. He trains individuals worldwide in the field of data engineering, while also leading business and data initiative at Toju Digital Payments, a prominent fintech company in Nigeria. Byron actively shares simplified insight on LinkedIn, making complicated data engineering concepts easily digestible for a broader audience. So no further ado, I'll stop sharing my screen and hand over the section to Byron. So Byron, over to you. So I'm going backstage right about now.
All right, thank you very much, Temidayo, and hope I'm loud and clear. Okay,
Perfect,
so
perfect, perfect.
okay, so thank you for the introduction, and I don't think there is need to do further introduction. So let's just get straight to what we are doing or what we came here for, and in the lack of proper words to give a title, so I'm going with this data engineering. Okay, because we are here to talk about data engineering, right? I don't know if you could see my screen. Is my screen visible?
It's visible, it's visible.
Okay. Oh, great. Thank you. Now, um, I probably would have loved to hear maybe one or two questions about data engineering from interested participants, but maybe let's just say we are warming up, right? So I'll just try to go further. Okay, now the thing is, before I go fully into the presentation proper or the discussion, I would want to try to touch on certain myths, a particular one that causes a lot of confusion in the field of, data. All right, so and it's simple. So people ask questions, and something like, what is the difference between data engineering, data analysis, data science, right? I don't know if um, because people still ask me that question frequently, and so I felt like, oh, this is what I should have probably included in my presentation. So since it's not here, I would just say, okay, let me just talk a little about it. Okay, and let me see if I could do something here for us to see. So let me just stop sharing this and see. Okay, so okay, I wanted to add something to the slide for us to see. And yeah, okay, so we'll just manage what I'm going to show us here. All right, so let me reshare this. Yeah, this is just like a poor a poor graphical thing. Like, I just had to pick it from somewhere to put here. So there's a unique, more like a well-renowned data engineer on LinkedIn. If people who have been following data engineering thing, you probably would not miss Zach Wilson. So he brought a very nice like representation of these roles. Okay, so he says that data analyst, it's there, and we have software engineering on another end. Now, this has nothing to do with which is better than the other. No, all these have their own functions, and I love the way he graphically explained this. Now we have the data analyst, who is 100% investigator. Okay, then when we go further, we have the data scientist. The data scientist is a combo of a large part of data analyst and a little part of software engineer. So he is a 75% investigator and 25% builder. Then when we go further, there is another thing called analytics engineer. Okay, now analytics engineer is more like a 50-50 combo. He's a 50% builder, and he's also a 50% investigator. Going further, we have data engineer. So you could see that data engineer is kind of very close to software engineer. So he's 75% builder and 25% investigator, while the software engineer is 100% builder. So what it means is that we have two extreme ends. We have the software engineer at an extreme end for building, applications, and he has nothing to do with, investigation. When we talk about investigation, is more or less related to analysis. All right. So investigating the data, finding out, getting insights and all those, extracting information from the data. So what the software engineer focuses solely on is building, solutions, building apps, building, infrastructure. Okay. Now, the data analyst on the other end has nothing to do with building. He's not building any infrastructure. He's not building anything. All he focuses on is to investigate the data, bring out information, focuses on extracting relevant information from the data. Okay, so now we have the likes of data science, analytics engineer, data engineer in between these two extremes. Okay, and we are here to focus on the data engineer. Fortunately or unfortunately, I think many job descriptions don't differentiate between a data engineer and an analytics engineer. So a data engineer kind of strains himself to also be an analytics engineer. That means by the current standard of things, a data engineer would have to be like a 50-50 person in terms of being a builder and being an investigator, if he or she really wants to be relevant in the workforce. And that is why you would hear when people are talking about data engineers, the focus also is on your understanding of SQL, the language for the database, because you have to do a lot of investigation of the data as well as building. Okay, so the data engineering field is a kind of broad, is a broad field, not even kind of, it's very broad. It's like a maze. A lot of people get confused, and I'm saying this because I have gotten a lot of confusion in this field, and the confusion spans across would like say environments or modes in terms of meeting the right set of persons to learn from them, or the right places to learn from. Different, you could meet people giving you different explanation of what data engineering is based on his or her experience, and then later on, after probably spending a lot in paying for fees and learning all those things, you get into the workforce and you are seeing a different description of what is needed for you to be a data engineer in their company, and then you get confused. All right, now the confusion is not just about learning. You can now get into the workforce trying to apply for jobs, and then you now hear different sets of, you could apply for like 10 different jobs, and in those 10 different jobs you have seen very different job descriptions, like 10 or 5 different job descriptions. And then when you start gathering these tool sets that are being required of you, at some point it becomes overwhelming because there become too many to learn. You hear about cloud infrastructure, you're talking about AWS, and there are many tools in AWS. Then you now get into Azure with the many tools in it. Then there is GCP there with the many tools in it. Then you still have third-party apps. And yes, I understand how overwhelming it could be. And that is why this session was created, just to help persons who are trying to get into data engineering, and also who have probably gotten into data engineering at an early stage, to see how they could find their feet early enough. All right, because it's not expected that everyone should come to start talking about their experience. Okay, like you don't have to pass through all those things. Okay, if you get the proper education. And for us, I believe that it has to do with you understanding why data engineering came into the existence. Okay, so that is why we have data engineering as just title. So why the data engineering? Okay, and so that takes us to history. When we talk about history, we're talking about back 2017. Data engineering actually existed before this time, but we're talking of when data engineering started becoming, appreciated. So it's the rise of big data is what birthed the data engineering craze. Okay, so when data became so much, it was, people were losing a lot of information, a lot of wisdom, a lot of insight. We are talking of from the big companies and the rest. So they've been trying to see how they could really get, insights from the data, because the available tools that were on ground, in the likes of data analysis and data science, could do a good amount of analysis, could do good amount of, creating models for predictions and the rest. But they realized that it wasn't enough to just analyze, it wasn't enough to just get insight, it wasn't enough to just do prediction. Now, there was something that was missing, because if that thing wasn't gotten properly, if it wasn't right, or gotten, if it wasn't gotten right, then even the analysis and the models that we built would have issues. So there were a lot of issues, and these are examples. 85% of big data projects failed. 87% of data science projects didn't make it to production. 20% of insights could not, were just probably delivered out of the 100%. So information was becoming risky in terms of, giving a proper analysis. It's somehow when you as an analyst create a kind of analysis for a business, and then it didn't work out well, but like it was like the analysis was wrong. And when you check all your tools and everything you use to do these things were actually correct, were right. So the issue was not the analysis itself. So they were trying to find the cause of this project failing and all those things. And one of those reasons was businesses were so focused on hiring only data scientists and probably data analysts. Okay, so they forgot that in this data field, to get the pure juice of data, you needed the full team of the data, including the analyst, the scientist, and then the engineer. But the engineer was a missing factor in all this. All right. So this is more like a Google Trend graph to show the history of how the data engineering thing came into action, right? So it has existed, like I said, long before now. You could see that even in 2004, discussions of data engineering continued, and then the rise started coming up, say from around say 2015 or going up. So it kept on rising. The knowledge of data engineering, the craze of it, and that is why data engineering currently hasn't really gotten a very standard measure. So it's still very wide. That unlike software engineering where you have the back end and the front end, data engineering is more like the back and front end are just together one estate. Okay, so you're like a full stack person. All right, so it's not long that the data engineering profession started becoming appreciated. So what is data engineering in essence? It's the practice of building infrastructure. Okay, so it's just a matter of collecting, storing, processing, and converting these things. So it is easy to just write down the explanation. A lot of people know data engineering as something about pipelines. Okay, so now let's go further to really get the essence of data engineering. Okay, so data engineering is not very complete if you don't mention the likes of big data. All right, so now we have people who call themselves data engineers, and we have some persons who differentiate themselves with big data engineers. Normally, the data engineer, the big data engineer are meant to mean one thing, okay? Because the real essence of data engineer comes out from the possibility of so much data that the normal tools may not be able to handle. Just like we have the Microsoft Excel, that you could have data into the Microsoft Excel. You could even use the Excel sheets or Google Sheets as databases, right? But they have their limits when the data becomes too much. There are even data engineering firms, tech companies that still rely on Excel and spreadsheets. In short, almost all cannot do without that package. But there is a kind of transaction that comes up that it's not possible to depend on the spreadsheet, because they have limits in terms of the amount of data that a sheet would contain. And at a point when the amount of data is large, even though it hasn't gotten to its limit, running some formulas or trying to access the sheet begins to portray challenges. Okay, so now the real challenge of data started coming up when it was becoming excessive. So we had like trillions of data that were coming out of all these companies on daily basis. Okay, we had more than trillions. All right, we had more than trillions. So it was so massive that everywhere was flooded with data. Up to now, everywhere is still flooded with data. So the data engineers are more like the plumbers that needs to come to see how the analytical team is not going to run analysis on just what they could afford or what they could get, but run proper analysis on the entirety of the data that is being produced from these systems. So how can they get all these? Because if the data analyst or the data scientist focus their time in trying to make sure that they channel all this data to themselves, at a point they may not be able to do their work properly. All right, because it would have been a shift of focus. Okay, so the question now was how can this big data be efficiently handled? How can this analysis, how can this building of models be efficiently done with big data? Now, IBM came with a discussion of data and says that there are three features that qualifies a data to be big. However, we have some other ones, but these are like considered now as the primary features before adding the other ones. So the volume of data, the velocity of data, the variety of data. All right. So that means when we talk about volume, we are talking of the size of data. So volumes, it is we can't really explain how efficient or how voluminous big data could be because it is definitely so big. All right. Velocity also talks about the speed, how often it takes to get into a system. Now, when you get into when you take your card to the ATM, you slot it in, you do your withdrawals. You would want to get an immediate response, isn't it? Now that is velocity, the speed of data, the speed of information, the speed of processing. It's velocity. You do your chart, you're on the Twitter, you send a chart, and you want a response immediately. Many persons are responding and feedbacks are coming in. That speed of like billions of posts are coming out of an app or of a from a location. And what kind of system can accommodate all those things without crashing for a long period? So that's the velocity. Okay, when we talk about variety, data don't come in just CSV or Excel. Data comes in different forms. Okay, we could have even the non-structured form. We could have everything. In short, everything about life now is kind of data. Everything uses data. Everything is sweat data. So they come in different forms. How can you gather all these forms and still bring out insights and still not miss the juice of data? So this is more like my explanation of how big data is in terms of volume. All right. So imagine the weight of all the world's elephants combined. And I don't think that is going to be an exaggeration, or maybe not too much of an exaggeration, of how voluminous big data is. Let's look at Jumia, a website that we are very familiar with, an e-commerce website. Okay, now this was it could be more than this now. So we are talking of 1, 2, 3, 4, 5, 6, 27 million products that are being found here on this site. 27 million products. All these products have images. Some of them have more than one image. All right. They have prices, they have other information that are attached to them. Now, this is a little example of how voluminous data could be. So you just imagine using your own personal system to download all the images on the Jumia website. You are kind of killing your system. No matter how powerful that system is, you will feel the impact when you successfully run the downloads. Okay, so that is how voluminous big data is. Then okay, I believe we understand, we see trains, we know what trains are. Now let's look at the bullet train in terms of the speed. And we are saying this is how data comes in velocity, when we are talking about velocity. This is the speed of data. Now, what applications can we use to really capture all this data? So based on the traditional applications that existed, yeah, it could only capture some of these data, all right? And so a lot of data were kind of falling by the way that they couldn't run insights from. Okay, now varieties. Okay, so this is like a sweet picture. All right, so variety to me is just like, you just finding it difficult to decide between what to choose. All right, sometimes that's how data is. Like, there are so many different types of data. So if your application or your tool cannot capture the different forms of data, then that means you are setting up whatever business you are trying to build insights for failure, because you are missing some important things because of the limitation of the tools to capture this data. All right. So we have other V's of data. Aside the volume, velocity, variety, there is veracity. Okay, that has to do with the truthfulness of it. Then there is value. Okay, so I would not want to get deep into that, but I feel understanding the three V's first is enough to really get a grasp of what data is. So based on these scenarios, you can see the challenges of data. The challenges of data cuts across the storage medium. Imagine storing that large amount of data. Okay, then the processing period. What kind of tools do you think could really process all this massive data, this very quick and fast data? Everybody is expecting this data, the result of this data to come within splits of a second. Okay, then when we are still trying to struggle with the storage and the processing, scaling now also becomes a problem. Because when we talk about scaling, we are saying that this data grows. So as you are trying to bring in something nice for the storage and for the processing, please do remember that it is not the same amount of data that you should expect. It is not just the frequency might increase. All right, so you need to put all those things into consideration so that your tool should be able to accept expansion. All right, so based on this, there was a need to build systems for data engineering process. All right, and up to now, systems are still being built. That is why one could learn a tool and then tomorrow is seeing some other things. We see orchestrations, we see airflow, then the next you are seeing prefect, then you are seeing other things. Okay, so this is because data engineering is still kind of new, and so systems are still being built to be able to accommodate these things. Have we solved the problems of data engineering? We've not entirely solved them. There are still issues. That means at the point, even the tools that you have could start giving some issues that you might need to support other tools and the rest. So if you don't understand the nature of big data, it might be difficult for you to grasp this field of data engineering. And if it is difficult for you to grasp it, then how do you want to survive the storms of the data engineering? So you need to understand where it's coming from, what is happening now, and where to go. So whenever you are journeying in data engineering, then it will be easy for you, at least to an extent, to understand your direction. Okay, so when we talk about the systems for data engineering, they are divided into two. We have the monolithic and we have the distributed. Okay, so I feel like I'm really talking a lot. I don't know if yeah, I would like to check the chat box so that I could get questions. All right, so I would be able to give you responses based on that. Okay, so I would continue. So I'll just be toggling between the chat box and that so that I could just pause to answer the questions. All right, so now monolithic and distributed systems are more like the major let's say the two ways to build a system, all right, for data engineering. So it is unfortunate that even some data engineers are still finding it difficult to understand these terms. And I will try as much as possible to break this down in a very simple manner so it will be easier for you to absorb it. All right. So all these things are still relatable to your real life experience, and you understand this at the end of this session. All right. So as the name implies, mono has to do with one. All right. Then distributed is opposite of that, so you should know that it's for multiple. All right. So now we have monolithic systems and we have distributed systems. And so in monolithic systems, we have tools that are being used for these kind of systems. In distributed systems too, we have tools that are being used for this kind of systems. Now, I've seen some persons interchanging these tools and having issues with it. Data engineers. Now, for monolithic, the tools for distributed could work in monolithic, but you would be wasting them. The tools for monolithic are less likely to work in distributed systems. And you understand why. Let me go further. So, like I said, monolithic is one. So, when we talk about monolithic, we are talking of one powerful system with a lot of resources. For example, you running data engineering from the processing, the building, and everything with your system, just your system, could be taken as a monolithic process. Okay, you are running your extraction, transformation, and all those things with it, and it's not a bad thing. It is, like I said, it is not. It is not. I'm not saying that it is red does not mean it's bad. Okay, so I'm not saying monolithic is it shouldn't be considered. This is not bad versus good. This is like trying to distinguish between two things. All right. Now, um, a lot of things that are being done in data engineering could be with monolithic and could be successful with that. All right. Now, another thing you need to understand about data engineering is that it is not about building, but it is about building well. Okay, it's not about building pipelines or trying to make something work. Something could work, but you didn't do it right. Now, I've seen a lot of talk, like seeing some memes and the rest about if the code is working, just leave it, don't touch it again. In data engineering, that may not work because it's not the focus is not just about it working. You constructing a pipeline and it is successfully extracting information, you are successfully transforming it and then loading it, and data analysts are very comfortable with the data that they are being presented with and they can run the analysis well. But you see, a proper data engineer, or let me not use that. Let's say a data engineer who is setting out to be valuable in a company or in an organization would always be thinking beyond just making it work, but thinking of the most effective way, and very important, the most cost effective way of doing it. All right. For example, distributed system might be more expensive, and probably you look at the job that this thing can be done based on the monolithic process, and then you convert everything to the monolithic process, at least for that meantime, and everything is working well, and you save the company that cost. Most times when you see data engineers applying for jobs and you are seeing like their CVs, many of them, one of the things in CVs is it will be good to represent, to put some numerical values, right? Attaching that to your experiences. Now, you see that many of these data engineers, when they're trying to present their CVs in terms of experience, there are some things that they put there. Okay, more like I saved the company a certain percentage of time. I saved the company a certain percentage of amount. I saved, those kind of things. Those are like very important things for a data engineer to always put into consideration. So that's why I'm saying that monolithic is not bad, okay, but you need to understand it to know when it will be bad. Distributed is also good, but it's not exactly just the savior. You also need to understand to know when it is bad or good. Okay, so we have monolithic and then we have distributed. So distributed has to do with many smaller systems joining their resources. All right, so I would explain further. So the question now is, what should we do? Should it be monolithic or should it be distributed? Okay, so now a monolithic system is a single powerful server. Okay, but it is not easy to add resources after a certain limit. Let's break it our usual system. Now you have a system, and probably you are discovering that your system is becoming slow. All right. So the next thing you are thinking of is to work on the memory, right? Maybe you have to increase the RAM size. You have to add more RAM or change it and bring something more upgraded. You have to change the hard disk, probably increase the hard disk and all those things. Now you have limited things to actually work on in terms of making your system more efficient, to the extent that many persons just decide to go buy a bigger system, a more powerful system. All right. So it's not that it's not possible to add resources, but the adding of resources are kind of restricted, and I will still explain further in the next slides. Okay. Now, these are the this is what we call compute, right? So these are the major things that has to do with the computing strength or power of a system: the memory, which is the RAM; the storage, okay, which is the hard disk; then the processor, okay. So it's mostly called like CPU cores, all right, which is, yeah, the processor. Now, these are the three things, and you see, for a normal system, it's not easy. When you're upgrading memories for something, there's a level of, can you hear me?
Yeah, you're back now.
Okay. Oh,
Yes.
sorry about that. Okay. So there's a level of getting of upgrading your system, that it's even the upgrade could also hamper the production of your system or the efficiency of your system. I don't know if any of you have experienced something like that. Like, you realize that, man, this memory is becoming like, maybe you get it to a repair and the repairer is telling you that, no, the what you put inside is kind of bigger than what it can contain, right? And so instead, your mind, you actually wanted to do that to increase the efficiency, but you put so much that it exceeded the limit, and then instead of increasing, it's even worsening the situation. All right. So those are the kind of limitations that comes with monolithic. All right. So, but if you have something, if what you want to process can work within the resources of the monolithic, that is cool. That is fine. It's just like saying Excel is bad, SQL is better. There are some points that what you need is just Excel. You would probably be wasting resources in putting the data in a Postgres database or a SQL database just because you really want to use the trending. No, no, no. That's wrong. The first thing you need to do is to understand the business case, all right? Then you choose the tool to use, all right? So, like I said when I started, you need to understand big data in a very reasonable way so that you understand the direction of data engineering. Okay. Now, is monolithic a scalable system? The truth is, based on what I've just explained, it is not scalable. Yeah, it's not scalable because monolithic. I just gave a scenario, okay, that you could add, RAM and all those things, and it doesn't. It's still giving you maybe a bad response because you've exceeded limits. But aside that, when you are processing data, and say you probably kind of running this particular data, and it takes you, say, maybe 20 minutes to download a particular data, you feel like when you add, like, probably you're using 4 gig RAM, okay, and then you believe that when you make it like an 8 gig RAM, it should happen like 2 times faster, right? Like, if it took 20 minutes with 4 gig RAM, it should take maybe 10 minutes with 8 gig RAM. That's like the hypothesis, right? But if you check very well after upgrading, it doesn't happen that way. Even when you change those other resources, it doesn't happen that way. So that is an explanation of why this is not exactly scalable. Okay, because the more you add resources, the resources you add could actually influence the effectiveness of it positively, but you can't run a calculation and say it's going to give you this percentage. So if you add 2 times the resources to that monolithic system, you don't it's definitely not going to give you the results, give you a 2 times better result because of those resources you added. All right. So that's it's difficult to really explain the scalability because you can't really quantify it with some kind of formula when it comes to monolithic, all right? Because there are other things that are involved, the processes and all those things that are going on the system that could also fight the computation, all right, or the resources, and share with the resources. And so your hypothesis would mostly be wrong whenever you add resources to meet up the processing power of your system, or let's say the performance. Okay, now when we talk about distributed system, it's let me break something down for us here. So we've heard about 5-node cluster, 6-node cluster, 10-node cluster, and the rest. Now let me try to be very simple so you understand what happens here. When you hear node means computer. So don't feel so overwhelmed by the technical jargons. All right, node is just computer. So when you hear something like 5-node cluster, cluster is an English term. All those things I mentioned are English terms, but let's understand it. When we talk about cluster, we are talking about things that are grouped together, isn't it? So you could just say a network of things, all right? So when we say 5-node cluster, what we are saying in essence is that there are 5 systems that have been networked together. The node, remember what I said, is a system, all right? So it's more like you probably are not seeing them, but they are physical systems that exist somewhere else. Okay, so like I said here, there are multiple small and cheap computers connected together to act as a single entity. So you can see there are 1, 2, 3, 4, 5, 6. All right, now you could count 7 here, but that's not how it's been explained. All right, so this one in the middle is more like the master of it. So it doesn't really do the work. All right, it doesn't really do the work. So this is the class captain. It supervises what other people do. So the cluster is being represented by the things that these other people do. That's why they are mostly called work. They are, in short, they are called worker nodes because they are the ones that do the activity. While the one that is in the middle is called a name node, okay, but is a master slave kind of thing. So the ones that are around are the ones doing the work, while the one in the middle is just more like the supervisor. All right. So when we are talking about the cluster, we don't count that master as part of, is a part of the cluster, but it doesn't qualify to be in the name of the cluster. So just understand that. So in this picture you are seeing here, you are seeing 3, 3, 6 plus 1 in the middle, 7, right? But it is called a 6-node cluster because the name comes from the workers. All right, so understand that. Okay, so when we talk about cluster, we are talking about it's just more of networking of systems together, all right, to do this work. Now each node, like I said, is a computer. So that means each node has its own hard disk, has its own memory, has its own CPU or processor. Okay, each node has its own hard disk, its own memory, and its own processor. Okay, so you compare this with a monolithic system. Say I have a file that works, that does, maybe it takes like maybe 20 minutes. Okay, it takes like 20 minutes to process on one system. Imagine doing this in a distributed system. How long do you think it will take for 6 systems to run that? I think this is a question I would like to get response from. So if it takes 20 minutes, okay, to run a particular file on one system, how long do you think it will take to run that same file on these 6 systems? Yes, please. You could just type it. This is how I know that, yeah, some persons are actually learning, because I want to be sure that, yeah, people have understood what I'm saying up to this point. Yes, just one person could just say something or type something and then would continue.
There are answers in the chat box.
Oh,
Are
are
you able
there?
to see?
Ah, I think maybe it's from my end. I'm not seeing the last statement I'm seeing here. Is any questions from anyone yet?
Yeah. There are like 4
Okay.
more after that.
Okay. So the
Okay,
first
okay,
person
okay,
said
okay.
3 minutes.
Do you see them now?
Yeah, I
I
can see
seen it.
them now.
Okay. Awesome.
Oh,
Yes, I had to. I think it's when I disconnected, so probably the chat just froze, so I had to
Okay.
restart it. Okay,
Okay.
so yes, 3 minutes, 3 minutes. If the processing allows parallelization, perhaps 20 divided by 6 minutes. Okay, 3.3 minutes. Okay, yeah. All right, so somebody has gone for that to explain. Yeah, if the processing allows parallelization. Okay, so that's where I'm coming to, and I agree with everybody's statements. Okay, so I'm trying to like make it very basic or very simple so that you could get my point. So I know that there are some persons there that already understand some of these concepts, but yeah, it's cool to know that there is a network here. Now, that is exactly what it is. But you can see that when it comes to the monolithic process, you can't run that calculation like what I said. You, even though you increase your RAM size and maybe there is a way you kind of worked on your processing power and the rest, you can't really conclude on that based on the formula. So what this means is that each system is going to work on a part of your file. And when you see in a distributed system, what works on the distributed system or the feature of a distributed system is that term called parallelization. Okay, so because they work parallelly. Okay, so I understand his point. Okay, so now there are other advanced methods to really explain the parallelization because there is a possibility that probably the file, when we talk about say the block size or when we talk about the tax, and I don't want to go into those complex things because what we are trying to talk about here is the journey. Okay, let's say the starter's journey, how to understand this. So let's assume that everything is right, that the file can comfortably be processed by these 6 systems, okay, in parallel manner. So that means these 6 systems will divide the file into 6 blocks or 6 locations, right? And then process only that part of the file. That is what parallelization in distributed system means. That means if I put a particular file into this system, the file I'm going to put is going to get into this system in the middle. All right. So this system now is going to have a way of sharing those files to all these particular systems in bits, okay, in different blocks. And then there is a process within it that knows how to still assemble all those things together at the end of it. All right. Now, unlike a monolithic system that is still going to receive the entire full 20 gig system or 20 gig file and run it, whether you increase resources or not. But in a distributed system, it only gives this system, let's say, three let's say if it is 20 gig now, that means it's probably giving it 3 gig each. Let's just run that assumption, okay, because there are like other deep processes beneath that could explain the exact amount of size that will be shared among these, but let's do this on the surface. Now that means that 20 gig file divided by 6 would be like maybe 3.3 gig or something, right? So that means instead of one system processing a whole 20 gig file, each of these systems are produced is actually processing just 3 gig of that particular file. And so you imagine what processing 3 gig is going to achieve. So as this monolithic system is still struggling to process all the 20 gigs, this particular process would have already completed long before it completes itself. Because the 3 gig, because this is just the same thing as saying this whole system is processing only 3 gig. That's what it means. Because each of them will be processing 3 gig individually at the same time. So if it takes 10 seconds to produce, your monolithic system could probably take 10 seconds to process 3 gig, right? So, but if maybe he wants to process 15 gig, that means it's going to take 30 seconds to process it, right? But in this case, if it is 15 gig and there are 3 systems connected together, then it will still produce that in 3 seconds. Why? Because each of them is producing just 5 gig, just 5 gig, all right? Each of them is producing just that particular 5 gig in 3 seconds. The monolithic can process 5 gig in 3 seconds too, but the total amount of data it's actually processing is 15 gig. I don't know if you get my point. So now what it means is that the time it will take to complete that whole amount, this system has completed it because it was a combination of systems that was handling just a little part of the file at the same time. So this is a kind of breakdown to understand the distributed system. Okay, so it's distributed scalable with all this explanation. Of course, that means if I need my process to run faster, maybe 2 times faster, I know what to do. That means if I probably double my systems, because you can increase the number of systems here. So it's more like there's a possibility that the data is kind of beyond even the cluster. So if it was the monolithic, all you need to do is to probably increase the size of hard disks, but in distributed, you are adding to the nodes, or you're adding to the cluster. Okay, so you're adding more nodes to the cluster. So that means it is easier to say that if 5 systems are going to produce, if 5 systems would produce like maybe 10 gig file in 10 minutes, then that means 10 systems should produce that same 10 gig file in 5 minutes. Because now it is easier for you to really explain scalability when it comes to distributed, because you can use a formula and it's going to give you exactly that. All right. So you can see the difference in scalability when it comes to monolithic and distributed. Okay. So all this explains that monolithic architecture scales vertically, distributed scales horizontally. So when we talk about vertically, it's more like you keep on adding to itself. It's just like somebody getting taller. All right. But when we talk of maybe an horizontal scaling, it's like somebody getting wider. Okay, but it's not exactly somebody getting wider. It's like adding more people beside somebody. All right. You cannot add somebody on top of somebody. So it's going to be more of the person getting taller. All right. And that has a limit. Okay, because no matter how you grow, there is always a limit to your height. Okay, but when it comes to distributed architecture, it's more like adding people to your side, and that does not have a limit. Like, it doesn't exactly have a limit, because you can add as many persons as possible to your side. Many people can come beside you. All right, so you can see that the true nature of scaling is horizontal scaling. So that's why horizontal scaling is called true scaling, while vertical scaling is mostly called not a true scaling. All right, so with this, you understand how these structures come into play. Okay, so these are more like differences. Like I said, that you are seeing a lot of X here doesn't mean that that the distributed system is the savior to monolithic. It could be in a way, but it all depends on the use case. Remember, what we are talking about is big data. Okay, it might not be difficult for you to understand normal data processing, because if you can run Excel, run SQL, and all those things, it's just the same way of understanding it. But if you are trying to talk about adding to your knowledge, then you need to really understand what big data is. Okay, I believe you've understood that big data is not just the size, even though it's called big. Okay, there are other factors that describes big data, although volume is always the first to consider, which is the size, but there are other things, okay, which has to do with the speed, how frequent the data comes into play, and the variety, the different forms of data that come on board, aside other things like veracity, okay, and value. We have some people even mention up to like 6 to 7 V's of data. All right, so these are all the things we've discussed, that when you read data from the source, store data, clean and transform data, convert data into insight, you can use the distributed system to even explain how efficient it can be when it comes to asserting those big V's. Just look at this now. we have large volumes of data coming in, it is easier to break it down into smaller parts and share among all these systems to run it at the same time. Okay, now let's look at what's the next, the velocity, right? The speed of data. So with this system, because it is quick for these people to process, all these nodes to process, so the speed might not really be much of an issue, because as quick as it comes, these ones will have already processed and continue processing as the data comes, because they are processing like in little bits. Okay, then when we talk about the different varieties of it, you could even use this particular distributed system to run some things and say, okay, maybe two of these systems from this network should process this variety, the other should process this other variety, and then so you could see that the challenges of big data is what bettered this distributed systems say architecture. All right, because this is the only kind of environment that can really try to match the volumes and the veracity and the variety, the value part, and the velocity of the data that comes in. Okay, so now that's I would say let me stop there. I'll say that's why all good big data systems are based on distributed architecture. Okay, so I would like to see if we have some more questions, and see if I could respond to that. There are
Okay.
tools actually that are being used, but let's start with some questions.
Okay, so there's one question. Oh, and by the way, awesome section. It's actually a lot. So there's a
Mm.
question from Prince. He said, how can you create or put together a personal distributed system that reduce the cost compared to that of Google? This word.
Okay. Okay, more like how could you create your own distributed system, right?
Yeah,
Okay.
let me make him a speaker so he can explain better. But I think that's
Okay.
what he said. So Prince, right? Prince. Oh, are you Prince? Mike, if you can help me and make him a speaker, I'm looking for him. I don't know. I can't find him on my screen.
Okay, let me try. You
Okay,
can also
I've seen
try to
him.
raise his
I've
hand.
seen him. I've seen him. Okay. So Prince, you can unmute yourself and speak.
Yes, my brother. Good afternoon, everyone, or good
Yeah.
afternoon from Nigeria. The question is really, you brought it down to a layman level when you compared it with PCs. So it just occurred to me that how can one put together such a system in a low-cost manner while achieving the same, while being able to process that quantum of data without incurring the same huge cost.
Okay. Yeah, thank you. So when we talk about costs, when we talk about huge costs, there's a possibility that your suggestion might even be the one to garner that cost. You get, but let me try to paraphrase what you're saying, in case just to be on the same line, that this is what you mean. So from my own understanding of your question, you're asking like if it's possible to have those systems by myself, like me making, because by the reason of distributed systems, it's the understanding we have is that we are not the ones in control of the computers, right? We connect to an already existing network of systems and cloud-based, like when we talk of AWS, GCP, and all those stuff, right? That's what you mean. So you're asking
Yes,
how
please.
how can we create that? Is it possible for us to create that particular network or that particular cluster with our
Yeah,
own resources, right?
yeah,
Okay, okay,
yeah.
great, awesome, thank you. So now let me still break it down to explain um, what you mean. So it's more like for others that would probably want to understand. So it's more like, since we said that this thing is a cluster, all right. So all these nodes are computers that are connected. So it shouldn't be difficult for me to also get number of computers, isn't it, to put together. It will still do the work. There's a way I could program it and all those stuff, and it's going to do the work because I have multiple systems coming together to process a particular data. Okay, so now that takes us to something that is a part of computing. Okay, so I would like call it computing model. So we have on-premise computing and we have cloud computing. Okay, so now there are organizations that do on-premise computing. So there are tools that also work for on-premise computing. In short, when distributed computing came into play, it was focused on on-premise. Okay, so I didn't get into talking about Hadoop because of time. I wouldn't want to like beat beyond the allotted time. So I didn't get into those things. Probably in another discussion, I would probably explain how those distributed came into play, the real structure itself, when we talk of Hadoop, HDFS, and all those things. All right. So Apache is a company that brought this Hadoop ecosystem. So now we had it was more like an environment that was created, but it was for on-premise purpose. So what happens was these systems come together. They bring different physical systems together to connect, and you run these things. All right, until cloud started coming into existence. It has not cloud has not kind of it has not like replaced on-premise. Okay, what cloud did was to kind of make it easier. So now coming back to your discussion, it is possible to get different systems to to function that way, but you need to understand why you are doing that. Okay, it takes us to the business case why you are doing that. So obviously the response has always been the data set is kind of very large and increasing, right? And so now there's a statement I made, and increasing, that is the scalability. So you discover that even though you succeed in getting some systems together to compute these things, what happens if these systems increase? If the files continue increasing, let's say you started a financial technology company and you're kind of collecting, you have like a large customer base that your system can occupy, and then you have because the information is kind of, you don't want it to go out, so you now buy like more systems to get, so that all the systems are going to contribute their resources to process this data, right? And it is working, but your business is expanding. You are going beyond the shores of that state. You are going to other states. You want to even go to the countries and go abroad and all those things and get other customers. Now that means the data is going to be increasing. The financial transactions are increasing. So that means you will always want to buy more systems to add to the network, to increase it, to expand it, to horizontally grow, which is a good thing. But considering the costs, you would have to spend money in buying those systems, the software we have to use to connect those systems, the configuration of those things. Not just that, you have to get a server, do all those things. You have to get a dedicated company and all those stuff. The security of those systems, buying like the cooling system just so that it's not going to falter and all those things. So at a point like this, you realize that the cost you are trying to run away from is what you are getting into. So the cloud computing actually came because of one of the major reasons for cloud computing, aside others, is because of the cost effectiveness of using it. Because look at another scenario with this same example. Something happens, and maybe something happened in one of the countries where there was an earthquake. You understand? And so you lost some customers there that couldn't transact for a while and all those things. So that has reduced the transactions for you. But you've already bought like 50 systems, and the transactions that are now happening can comfortably happen within 20 systems. You've wasted 30 systems now because scalability does not just mean increasing, but scalability means increasing or decreasing. So now if it is in cloud computing, you don't have to bother much about the scalability, all right? Because if the data reduces, there's a way you can configure with the company that when the data reduces, the system, the number of computers or nodes that are attached to the cluster could be reduced to accommodate that. And reducing that means that the cost of paying for all those computers would also reduce. I believe you understand my points, right? So, but if you bought those systems, even though the data reduces and the rest, the cost you will be paying for those other 30 systems that are lying idle. You still have to be maintaining them. You still have to be paying for security. You still have to be doing the cooling effect. All right. So that is why when it comes to, it is possible to create your own on-premise network, but the cost, if cost is what is at the forefront, then it's not a very good way to go. So cloud computing is there because of this cost. So now I don't need to start, wrapping my brain on getting the systems and all those stuff. Another thing is the time to even get all those systems to compile. You are running your business and these transactions are increasing day by day. All right. Or maybe you did expect transactions to just come in bulk like that. You cannot just get to the market and get all the things you need and come and set it up within just few seconds. But if you are using cloud computing, it's you detect that this thing has increased. You just order for those things, and immediately within seconds or minutes, those nodes have been added to your cluster, and everything processes the new files. Okay, so in terms of the speed of handling things, the cost effectiveness, and all those things, the cloud computing is a better way to go. Okay, on premise is possible, but if the business use case is not very strong that will really require on premise, then it will be like you would be, I would say, would I say, wasting resources or not be very good in optimizing your process. I don't know if I touched your answer properly.
Okay.
Yes, yes, that was very helpful. That was
Okay.
very helpful. Thanks.
Okay,
Awesome,
great.
awesome.
You're welcome.
So there are other questions. Okay. So this one is from Michael. He said, okay, is DevOps mandatory for learning data engineering? So for data engineering, is DevOps mandatory? DevOps.
Okay. Like I said, data engineering is an evolving thing. Okay. So when we say DevOps, I think we should break it for the sake of persons. So when we say DevOps, we are talking of like say, how will I put this now? It's more like principles and practices, right? Like a software development approach, right? Principles and practices of how to really, let me just say the life cycle of a software development, right? So the thing is, for now, it's not exactly mandatory, okay? But looking at the future of data engineering, like I said, it's still new. So all those things are things that will still come on board, all right? Probably at that time, we would have like, like data engineering being segmented, okay? But with the little stuff that is available, a, a kind of DevOps activities are also going on in data engineering. Things keep on coming on board. Like last I knew, CI/CD was not like very big thing in data engineering, but now many persons are kind of bringing a kind of crusade for something like that. Okay, so what I would just say is for data engineering, for people that are starting, you try as much as possible not to get into everything. That is why I had to start this session with talking about the history, the whys. So if what you are doing, you start with the basic parts. As you expand, you will start meeting all those things. The likes of DevOps and all those things, even like security, all those things come up based on the business use case. Security is very necessary actually, but you cannot be a data engineer and you will not know that part. It's part of what you always do. But when you are taking it like a core thing to focus on, then you might be deviating from what data engineering is as at now. Okay. So in terms of DevOps, I wouldn't give a yes no question to that. Okay. It is necessary because when we talk of data engineering, it's still like a development cycle process, right? So if all those practices are put into place, all those principles are put into place, it's definitely going to make the efficiency of the system up there. But when we talk about learning data engineering, it's not very advisable to start considering those things at an early stage. don't know if you get my points. That would be my my 2 cents on that.
Okay. So best practice. Um. So another
Yeah, sorry,
question.
sorry, 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 Temida. So now I'm not saying that best practices should not be considered in data engineering. What I'm saying is that there are practices that are going to be considered definitely, all right, to make it, because optimization and all those things, there are rules of engagement in, creating your infrastructures and doing all those things, even in your database optimizations and all those stuff, right? So like windowing, bucketing, partitioning, there are rules in doing all those things. But the thing is, when I'm looking at DevOps, I'm looking at something like a major field on its own. So you don't have to start, so that someone who is starting is not going to consider going to learn DevOps before coming to get this. All right. So there are basic things in terms of principles and all those things that are being handled while learning data engineering. That should be sufficient for that stage of learning, of getting into data engineering. As you go forward, you could decide to break it down and focus on maybe this DevOps part of data engineering. Okay, so yeah.
Awesome. Okay. So another question. I think we still have like 2 or 3 more. From Bumi, she
Okay.
said, "Okay, thanks for your presentation." She said, "Okay, she has a question.
Okay.
What
Okay.
platform or boot camp would you recommend that has a structured curriculum to take one from newbie to a competent data engineer?"
Anyway, okay. So in a strong sincerity, I I wouldn't give I wouldn't want to talk down on some things, because I don't really know. It's not like I've attended all those boot camps, okay? But you see, data engineering boot camp is rare, all right? So, but I would just talk about what's the ones I have seen, all right? Temidayo, is there a data engineering curriculum in Nosebridge?
No, we don't have data engineering curriculum. Your page.
Okay, because it might not be safe if there was the data engineering curriculum here, and I'm trying to talk about yeah. So personally, currently I'm the data engineering lead in 10 Analytics. Okay, so the so it definitely would, that we are going to try our best to push people, and this the more reason why I'm bringing a presentation like this, because of the kind of persons have related with, and it's out of pain I I had to bring up something like this, because I see that a lot of persons have issues in getting the right teaching. Okay, I know how much have I could like go through a lot of resources, videos, write-ups, only for me to eventually realize that, wow, this thing is this simple. Because it's not easy to get technical people that really teach well. Okay, so it takes some level of passion and sacrifice, especially to novice. So that is what we are trying to achieve in this looks like marketing analytics, but that's the truth anyway, because I don't know any other one, especially in Nigeria. Okay, now the few other ones that I know are very expensive. Like I talked about Zach Wilson, right? So when I started, he is also creating his boot camp. But most of the boot camps for data engineering that I've seen,
I don't know. I think it went off. Michael, can you hear me?
And also, too, I'm no longer hearing Byron.
Okay.
But
Um.
it could be his mic, because even the icon that blinks when you are talking on your that blinks on your team's name
It's
is
not
not blinking
blinking.
on you.
Yeah.
It looks like a mic.
Byron, I don't know. Let me try
Maybe he's
calling.
trying to fix it.
Can
I
I
see
try
he's
calling?
muted himself. Maybe you.
okay, I'm back.
Okay.
Yes, now, yes.
Yeah, very sorry about that. So I had the Wi-Fi issue, and so I just switched to mobile. But I don't know how this do not disturb is still accepting calls. Okay, so yeah, I was talking about the different things. The thing is that from the things I've experienced personally, I would say that I'm not trying to discourage you, but I want to give you like the best possible guide from my own experience. So the thing is, it's not really that easy to get like a good lecture or a good place to to develop yourself. I have paid some good money in an academy when I started, and it was when I left I realized that chai, man, looks like I wasted this number of months. Not that I didn't learn something, but it wasn't like so valuable. Everything was more of the basic kind of thing. All right. So then I got into another one. There is an academy I also attended in India. They are very great, but they have prerequisites. Like you have to know you have to know data engineering to a particular level, okay, before you get into it, because nobody is ready to teach you SQL, Python from what is integers and strings. All right. So, but funny enough, I encountered 10 Analytics, yeah. So, and 10 Analytics is an academy that teaches from zero to hero level. And so I'm just new there. I accepted the job because it was like accepting a challenge, all right? Because I really wanted to be part of the system that would build people from zero level to hero. I know it's not easy because with the experience that I've had so far, that's what could probably dictate the kind of presentation I made, because I'm expecting that I'm meeting persons that are probably even trying to understand copy and paste to a certain level. So how would they want to know data engineering? So like I said, the data engineering field is kind of new and a lot of people are finding it. I had an issue with somebody recently. I think was it yeah, and he asked for mentorship. I don't know the person, and so maybe I wasn't. I just tried to explain to the person about me not very much being available, but I could respond to his questions and try to give my own piece of advice. Okay, if you want to meet somebody for mentoring, it's not good to like just bash into the person's chat and say I want you to mentor me. You guys never had this relationship or something. That could happen with a lot of data engineers because of the possibility of how hard and difficult and expensive it took them to get to even this level of knowledge they had. So it's not really easy to get this combo of stuff. All right. So but I believe that in very little time now, things will begin to align. So based on all this, for now I can be certain because this is my department, it's my unit. I'm in charge of the curriculum, and part of trying to get like capable hands to lead the team, right? So I'm sure of 10 analytics for now. Okay, 10 analytics for now. I'm sure of them for now because currently I've seen people from zero level, and the batch I'm handling now, we got into Linux and Bash scripts, and I can see that it's like a testimony for me to see people from zero level really knowing these things to this point. But how many persons really want to go to that level of sacrifice to bring people from this stage? So it's difficult to really get teaching from really zero level to the high level of, but I believe they will exist, but I have not really met a lot of that. So the only one I can talk of is where I'm working currently, which I'm sure of what they can offer, which is 10 analytics. Yeah.
Okay. Awesome, awesome, awesome. There's some more question. We've gone way, way, way behind time. Okay, I'll just take one more question, and that's from Michael. How can people easily build a personal work portfolio in data engineering? What platform do you use? Is it GitHub, Snowflakes, Databricks, Spark, or Azure?
Is it? Could you give the
Okay, he
list
said,
again?
how can people
Okay.
easily
Should
build
I
personal?
maybe?
Okay.
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 All right. So the question is more on people moving into data engineering, right?
Yeah.
It's a field where you know by doing. That's the only currency for showing that you know something.
Yeah.
So
True.
when you learn, then you also want to build body of work. And
Mm-hmm.
at first, you have to do things on your own personal portfolio level first So the question is, what platforms do you recommend for people to use to build up their personal portfolio? So that's the
Okay.
question.
Okay. All right. Thank you. So the thing is it's not it's GitHub is very okay. GitHub is very okay. You don't have to go extra, all right? Because it's not just about the presentation. It's about you knowing, like what you explained is, it's more of showing, right? So GitHub is personally, I'm not sure I have any other thing aside GitHub, and yeah. So it's there are other things. There are other things that I'm not sure the time will allow us to discuss this. Maybe tell me that we might talk about like how to really put yourself out there as a data engineer, right? Like like in terms of there are other things
Awesome.
like
Awesome.
there are other things like technical writing, all those things, because there's so much noise in the world, right? So you just need to find a way to make your voice known. But if the major thing is you need to get your hands dirty, all right? You need to get your hands dirty. Do projects as many as possible that you can, all right? Put them on GitHub, because it's the project that gives you the confidence. Okay. Now, even when you put your CV in, they're not kind of looking for. There's no specific place that they try to find out what you do. So anything, any link you put probably on your CV or wherever, the recruiter or whoever is interested can check it up. Okay, and see the project and try to be convinced. But the major thing is when you meet the person, okay, what will you have to offer? So that's the thing about data engineering. It's more about what you've done. It's what you've done that gives you the confidence. I think that's like the main thing. The major thing about data engineering is that confidence to be a data engineer. And that confidence only comes from your putting your hands to the plow, you're doing these things. If you just know all those things, know the theoretical knowledge and all those stuff, it's just theory. But when you meet like some kind of interview, there are some questions that will come to you and it will be difficult for you to answer on the same thing that you felt you know so much because you never experienced it. So experience is what gives you the confidence in this field. And so any platform that you feel it's comfortable for you to display or put your portfolio is very okay. Majorly GitHub, that's what most of us use.
Awesome. Awesome. Maybe we might do another section where you talk about putting yourself out there. We just look for a date and when you're most convenient and it's okay for you. So I think we'll be rounding up. I don't know. Okay, the last two questions, which I said I was going to ask you at the end of the section, Byron.
Yeah.
How you started your old data journey, which is actually very interesting, and also what advice do you have for people they're just starting out in the field of data? So if you can just help us like fit fast, we appreciate.
Okay, thank you. So I'll just try to be fast. So the my data engineering journey could be somehow lengthy, but I'll just cut it short because of time. I accidentally got into it. That's the thing. So there's something about network location, all those kind of things matter in life. So you could be doing something and don't know that this is what you're doing because you probably are not with like minds or something like that. So I had been in love with data, doing things with data. I was like, I was like very strong person when it comes to spreadsheets. I was like a maven with Google Sheets. I was, I at a point I was creating solutions to people. I really don't. I was interested in software engineering first, so I started going into software engineering. But at the point, I just got into business dev. Then, found myself solving problems. I think it happened that COVID time when I really got into it that bad. So I just found myself solving problems with people with the limited resources I had, which was Google Sheets. So I wanted to convert Google Sheets to an ERP. So I took that as a challenge, right? So I had the knowledge of JavaScript and Google Sheets could use AppScript. So I started converting, creating dashboards, dynamic things, made menu buttons and all those stuff with Google Sheets. So people, instead of paying so much with the likes of Sage and the rest, they could use my Google Sheets to run their entire business operations, stock their this data, find out who is owing them and all those things. So it was really doing the exact work that ERP was doing. So along the line, I tried to research further to understand if there's a pathway with this, and I saw data analysis. So I went further in trying to learn the other tools that would be required. So then got a job in data analysis, and then continue that way. So I applied for an academy and I applied for data science because I didn't even know what data engineering was. And then somehow, I don't know if they thought it's data engineering I wanted to go for, but I feel like they just introduced data engineering, so they wanted to push some persons there. So I was one of the pushed people there, and I got in love with it, and I think I preferred it to what I wanted to go for, and so I decided to stick my nose to it. And since then, I've enjoyed data engineering, although it's been very challenging because of what I explained, trying to really get the juice of it. People talking about something and it's not clear enough, only for you to discover after like 20 videos and blogs and write-ups to discover that this thing should have just been said this way and somebody will easily understand it. Yeah, so that has been the journey until now. Okay, so I also tried other academies, got courses on Udemy, followed people on LinkedIn that were in that field, checked out their posts and tried to enforce myself to really bring this. So I noticed that if I keep on talking about data engineering things, I'm challenging myself to learn more so that I'm not going to say the wrong thing. And so that's when I started improving on my posts on LinkedIn, trying to be frequent on it. So all those things are kind of you know, part of the journey that led me to this and still leading me to where I'm going to. Yeah. Yeah. So the next one was about my advice to persons. So it's more of about when you are getting into tech in general, and be ready for frustrations. So it's not, even though we know that there is a better tomorrow from it, but always be ready for that. So that is going to lead you into knowing that okay, you need to be disciplined with the things you are doing and all those stuff because when you are troubleshooting things, when things are not working out the way it should, just get ready for that. So it requires some level of determination anyway. But the major thing is like minds, network, try to always make every day a try to always be a data engineer like almost on daily basis. Just try to push further, try to know more, try to do things, try to set goals for data engineering, and be careful not to be overwhelmed by the things you see because when you see a lot of things, be careful. So I understand when somebody is asking of a boot camp or something that does that. I even understand better when someone requested for mentorship on LinkedIn and felt bad with the response. So because it's not easy to get the proper direction, but this thing is taking it bit by bit. Okay, but how do you know the bit? So network, I'm sure the media is very good when it comes to guiding persons and all those things. So if you don't know people in the field, at least you know some persons in this use bridge, so you could just contact one of them and ask for like a guideline, and they could kind of connect you to see how you could have learning these things in bits, even though it's to start from Python and all those things. But do not be overwhelmed by the things you see. Don't feel so bad. Don't start measuring your learning process with the demands outside. Okay, so because growth is not something that should be neglected in any kind of process, and learning data engineering requires you to really remember that always, that you are growing. So even though you've not gotten to that point, just make sure that you are growing, and before you know, when you look back, you realize that you know so many tools, and you start seeing some job descriptions later on and seeing that a large percentage of what they need you already have. So just grow. That's just it.
Awesome, awesome, awesome. That's a lot. And for some of you that might be interested, you can also follow Byron on LinkedIn. He's actually very active on LinkedIn, always posting. Like I actually learn a lot from him on LinkedIn. When he posts stuff, I'm like, wow, okay, so I can do this like this, which is actually amazing.
Thank
So
you.
someone's asking about the recording. So the recording will be made available on our YouTube channel. I've also dropped the link in the chat box, so you can check the recording out. So I'll just share my screen for like 2 minutes. So I'll just tell you about the next section. So we're having another section for Power BI. So for some of you that might be interested, you can join us by 6. That's less than that's 29 minutes from now. So we're having using Visual Studio to do C# scripting for Tabular Editor. I don't know what that is. But that's why I want to join also. So you guys can just join us by 6. I will drop the link in the chat box. So for some of you, can just place in a reservation and join us by 6. So everyone, I would say have a lovely week ahead. I know there's public holiday coming up, but we're in Nigeria this week. So for everyone else, have a lovely week ahead. So I'll stop the recording. I'll say bye, guys. Thank you, Byron. Amazing section. Amazing section.